It simply can't step outside those rules. If Orch OR is correct, then the brain is not bound by such rules. Each moment of gravity-induced collapse taps into this non-computable physics, allowing for genuine flashes of insight that aren't just the logical output of a previous state. This would mean that human consciousness possesses a quality that artificial intelligence, as we currently conceive it, could never replicate. We could build machines that are incredibly intelligent, but we could never program them to be truly conscious. This creates a stark, dramatic dividing line between humans and machines. In the computationalist view, like GNW and IIT, consciousness is a difference of degree. A sufficiently complex machine could cross the threshold, but in the Penrose-Hameroff view, it's a difference in kind. Consciousness depends on a specific physical process tied to quantum gravity, a process that is likely impossible to simulate. This would elevate biological life, or at least life with microtubule-like structures, to a special place in the cosmos. It would mean that the stuff we're made of is not just incidental, but actually essential to the nature of our minds. Our carbon-based biology would be a requirement, not just a historical accident. So the debate really boils down to a fundamental question about the nature of reality. Is the universe a giant computer and the brain just a smaller one running a special program we call consciousness? Or is the universe something more? A place where the laws of physics include a non-computable element of spontaneous state selection, a process that the brain has uniquely evolved to harness? For decades, this has been a fascinating but largely philosophical debate. For decades, the chasm between computational and quantum theories of consciousness seemed totally unbridgeable, a domain of pure philosophical debate. Proponents of models like GNW and IIT argued that consciousness is all about the pattern of information, while Orch OR proponents claimed it was about a physical process tied to gravity. But without a way to actually test these competing claims, the conversation stayed kind of stuck. I mean, how could you possibly design an experiment to distinguish between a complex algorithm and a gravity-induced quantum collapse happening deep inside a neuron? The beauty of the Orch OR theory, though, is that its radical nature contains the seeds of its own potential falsification. It makes a very specific, very physical, and therefore very testable prediction. The key lies in the central equation of objective reduction tau equals h bar divided by EG. This equation says that the time it takes for a conscious moment to occur, tau is directly dependent on the gravitational self-energy, EG, of the superposition. This energy, in turn, depends on the amount of mass involved and how far it's separated from itself in the superposition. So, this gives us a crucial variable that, in principle, we can manipulate mass. If we could find a way to subtly change the mass of the components involved in the supposed quantum state without changing anything else about the system's chemistry or computational structure, we could see if it affects the timing of conscious processes. And this is the experimental showdown we've all been waiting for. This leads to the design of what we can call the mass invariance test. The logic here is beautifully simple. First, you identify a neural correlate of consciousness, a measurable brain activity that's tightly linked to conscious experience. A prime candidate is the 40 Hz gamma band brainwave, which Orch OR specifically associates with the frequency of its collapse events